Good morning, physics. Good morning, Gabriella. Good morning, Jocelyn. Good morning. Wait, oh, you were about to say hello, Gabriella. You know it. You were about to unmute. I know you were. Okay, but it's no pressure, no pressure. Okay, good morning, Lunar. Good morning, Nadine. Possibly Atron J. Good morning. Oh, okay, awesome, awesome. Okay. Okay, I'm gonna stop. I don't mean to comment on people's like that's the whole reason people don't show videos, so people won't comment on them. All right. Good morning, Sydney. Oh, by the way, to everybody. So some people are asking, and not to call attention, but positively, what Sydney's doing is what I mean by an animated avatar. Like, people were asking, or so there's a portal for that, right? Seriously. But then like. I'm going to continue the good mornings. Good morning, Norma. Good morning, Rebecca. Good morning, Melanie. And let me make clear that each one of them is what I would call an avatar. I never pronounce that word correctly. Like, and maybe I'm not using the terms exactly correctly, but like they're getting points for just the mere fact that it's not a black box. Like that it's any, and even if you just put an initial, like I think that's an option, a Zoom option or something. Even if like I just had a square that just said D for D or Y for Yaverbaum, that counts. It's like anything to break up the black squares and just like distinguish yourself counts as an avatar. So anytime or every time you do that, you can put that in the portal for avatar. But if you're doing the thing that Sydney's doing, and again, I'm not making a comparison, I'm just, identifying. If you're doing the thing that Sydney's doing, that like is a
Fine.
feature in Zoom that you have to set up. It takes but it's like helpful and cool, whatever, and it's fun. And so I think that's like, a little bit more points. Sorry, hold on one second. And again, any one of these kind of things and then of course they're showing video, which the other people are doing, which I think is a little bit more point, or I'll check what it should be a little bit more point. But, um, and again, just for people who are still getting used to it, anytime you do that, you can submit for points and then you just keep re-uploading the screenshots and you just keep getting points. Okay, but I think most people do get that. I just wanted to make clear that that is an animated avatar. Okay, who else did I not say hello to? Oh, now the chat. And you get points for putting things in the chat. Um, Message. Wait, sorry, people still coming in. So good morning, Nadine, for the double. Excuse me. Good morning, Angelina. Good morning. Interesting. Why? Wait a minute. I'm learning something about Zoom right now. Why? It's telling me something I don't understand. All right. Good morning, Effie. Good morning, Gabriella. Good morning, Chanel. Good morning, Jocelyn for the double. Good morning, Sydney. All right, for the double. Good morning, Lunar. Good morning, Sinead. Sorry. Good morning, Rebecca. Good morning, Melanie, for the double. Good morning, Teresa. Good morning, Chris. Excuse me. Morning, Christopher. Good morning, Mohammed. Good morning, Genesis. Good morning, Alexis, ma'am. Oh, I'll take it. Yeah, good morning. Okay, so I think that's why something funny in the chat. Okay, okay, but I think we're good. We're good. Okay, and quick. All right, so we're gonna do like more physics, and as you know, we don't have we don't have class on Monday, you know this, right? I mean, we don't have school at all on Monday, religious observance, so no work is expected of you on Monday or Tuesday, regardless of you get my point. But then we reunite on Wednesday. Tell me if that's wrong. And quick logistical question also on that. Um, you have Professor Lou for lab.
Yes, sir.
Oh, so, yes, sorry, yes.
We actually don't have class on Wednesday as well.
Oh, thank you. Oh, okay. Thank you. I'm glad first of all, that goes in the portal for respectfully corrected. You're right. Okay, thank you for that correction. So we don't, and of course I should know this, but we don't have school Monday, Tuesday, or Wednesday. Is that? That's what Muhammad is saying. That's what you're all saying. Okay, thank you. Actually, so did I accidentally assign something for, wait, hold on. Let me just check really. I thought I had adjusted the assignments in light of this, but maybe I did it wrong. I'm going to just check really quickly. And I know someone's in the waiting room. Sorry, pardon me for saying two things at once. Okay. Um, 20. Oh, no, okay, we're good. Right. So I did take that into account. Okay, I guess I knew that at some point. All right, but thank you. Yes, so we don't have school next week. And so I do recommend, I'll just say this. I mean, the next homework is not easy. I don't know. I think the leap from homework three to, excuse me, the leap from homework two to three is a very big leap. I keep saying that just because I want you to know that I know. I don't think the leap from three to four is as large. But if three rattled you, then of course four will rattle you temporarily. I recommend, since we do have this whole week, and some people can't do work at all during that week, so there's nothing new. But use it as catch-up time. What I think I'm caught up with you guys right now. I want to get to physics, but logistically, I really think you guys are getting the routine. Like there are people that submitted a first draft of a homework on time. They got a bulk of points, but not all the points. They didn't see any feedback or comments on it. They listened in class. Then they thought after basic or some people whatever, then they listened in class, so some people based on class corrected what they did in the homework and re-uploaded it and then got all the points, and some, and I hope I made it clear to you that I know who you are, like four of you or something on at least one assignment. It might have been assignment one or it might have been assignment two. Like at least four of you did the homework, did it on time, got a bulk of points but not all the points, then listened in class, and then went back and looked at it and were like, no, I think it's good. I don't actually think there's any problem with this. Like, class was fun. Thank you, Yaverbound. But like, I am confident that I did it all right. And then those four people just re-uploaded the same thing, basically like, look over here, Yaverbound. And it got re-uploaded, and I got notified. And then I looked carefully at both the drafts. When the second draft was up, I looked more carefully at the second draft. And yes, I could see, oh, they didn't even make any changes, but they're just basically telling me, dude, I'm really confident of this. Like, I think I'm getting all, and if I'm not getting all the points, I want to know why. And at least four people, well, some people did then get comments like, okay, though this is what's going on, you can still get the points. But at least four people then just got all the points by doing that. So that's just my way of saying, I'm not going to name any names, but this is my way of saying thank you. I think you get it. Like that's how it works. Like, it often will take me till the second revision to really get something out of me. But so if you don't think that there's anything you need to do, then you just re-upload and great. But so I think everybody's got anything that anybody's done, I think, unless they just did it in the last 2 minutes, they've gotten it back. So that's good. Long way of saying in the next, since we have a lot of time after, yeah, since we have a whole nother week, go back and revise anything that you haven't gotten all the points on and try to work, I mean, on this current acceleration stuff, it's not a joke, and we're just getting into it now. And I'm not forgetting about train of thought. I promise you we're going to go back to train of thought when we come back. From the religious observances, uh, is that some, sorry, one thing, is it someone in the chat? No, okay.
Professor, look, you have a special guest.
Oh my gosh, I see. Hello, good to see you. Good to
Oh,
see. If that man survived the two courses, any of you can. Okay, I'm just no, that's not nice. Okay, he's the MSBS now. Wow. See, there's always a place to go from all this. Quick question. I want to get back to the physics, but last logistical thing, because we haven't really connected on this issue yet. Well, again, train of thought, we will. It's not forgotten. You'll just appreciate it more if we've like made a little bit more progress with the mathematical stuff. But speaking of that, of progress, you have Professor Lou for lab on Fridays. Is that correct?
Correct.
Yes. Okay. And so thank you. And anybody who just said that, especially if you use your voice. Oh, and all of you and the yes, sir. I don't know what to do with this sir thing. I mean, I kind of do like it, but not really. Yes, I do. So you have done with her, um, you have done two labs with her so far? Yes. Okay. So lab two, of course, was kind of tricky. I know lab two is tricky. I'm not going to get into a whole discussion right now. I'm going to circle, but it is intentional. I hope you realize, well, maybe I will say, well, actually, let me say this. No, I will say this. Is your formal report for lab two, is that due this Friday? No, oh no, that lab one, what is due this Friday?
It's labs two post lab.
Lab two post lab, perfect. Okay, great. Okay, so I'm going to bear that in mind as I talk today. Like it is intention, it is on purpose that you do lab two before you know anything about acceleration or gravity or anything. Like it's supposed to introduce you into that. But now we're starting to get the more refined details of acceleration and ultimately free fall. Then that will help you a lot by the time you write your formal report. You can even feel free to remind me. You can always remind me, all of you, I should say this. When you have a formal report due, when we have a class, like if you have a formal report due on a Friday and we have class Wednesday, you are welcome. You are strongly encouraged, any of you, in the chat or anything at the beginning of the class to sort of remind me and say, by the way, Professor, we have a formal report due this Friday. Any comments you could make to help us would be helpful, or could we ask some questions about it? You are welcome to do that. Like maybe sometimes I might not be as some I have to allocate my time, but we are really wanting the two parts of this class are very much meant to be connected. And we know, and the more that you guys and I can keep in communication about what you're doing in lab and whether you're nervous about it or why or what your issues are, the better for everybody. So you're always welcome. I mean, particularly on the day before a formal report is due, to remind me what formal report, and I'll try to gear my teaching toward that too to help you. I think you'll be fine with the post lab this Friday. Have the last thing about there's something in the chat. I'm going to look in the chat in 1 second. I'll look in the chat right now. Hold on, hold on. Oh, lab two. You're starting lab three. Lab two post lab. Okay, great, great, great. Okay, right. So lab two post lab. So I think, I mean, I will try even in my mind when I'm talking about this when we get started now. When we talk about acceleration, I'll try to gear some of my comments just to general things that might help you with the post lab. But post lab is called post lab for a reason. Like it's usually most of it is answerable just based on what you literally experienced in the lab. That doesn't, you don't have to have all of the lecture concepts in place to do a post lab usually. So, okay, but so that's good. But I will also warn you, if you're starting lab three this Friday, Lab three will be another leap forward. It will be into two-dimensional motion, which we have not said anything about in the lecture. So, but it's fun in a totally different way from lab two. Honestly, I don't think it's as challenging or as confusing as lab two. I think you'll find it more straightforward. It's different. But I wanted just since I've never made this speech before, it's all lab is like homework in that you're doing stuff to find out stuff. We always know, you should know that we always know that when you get to a topic in lab, that is often the introduction of that topic. It's not assumed that you've already seen that topic in the lecture. It reverse. So you're going to start seeing something two-dimensional in the lab through any information you need to do that lab will be provided in the lab. It is not assumed that you should be carrying any ideas from lecture to that. So don't be, and that will, and by the time you do lab four, which is fairly serious, you will have gotten all the lecture concepts you need for lab four. But that's just, you may have already figured this out, but it's just so that you shouldn't get yourself upset or get upset at the lab professor or something if you walk in and it's like a new idea. That is the idea. Okay. Last thing, has she ever said any, this changes sometimes from semester. Has she said anything to you guys about quizzes in lab?
Great question.
Oh, yeah, sorry. I heard voices, but yeah, it's a yeah. Sorry.
We
Yeah.
had a quiz last time.
Oh, you already had, great. Okay. So you know how they were. Fantastic. Okay. All right. But the bottom line, I know I just spent a lot of time. OpenAtion lab is totally part of this class. Like, you get one grade for the, so you're allowed, you're encouraged to bring up lab issues in this room. Like, I love it. I actually love when that happens. It makes me know better what's going on in your lot. Like, it's good. It's not off the topic to bring up lab things in this Zoom. Okay, that's my announcement on that. Okay, so let's get back to the homework, etc. What's on the board, as often is the case, the two equations that are in the circle at the top, I believe, is where we sort of landed last Monday. I think they're the conclusion of what we were discussing 2 days ago, right? But what we're really trying to, two quick things to the equations at the top is what we've already said. The equation underneath is where the ship is heading today. Like, okay. But as far as the equations on the top, like the review or the last beat from Monday, a couple of takeaways there. You might want to write these down in the notes for note-taking portal. One, notice the left side of what these new equations. The left side is an A. Yeah, obviously it's an A for acceleration, but notice it very deliberately does not have a bar on top of it, right? Anything with a bar means average. We do have an equation for average acceleration. We wrote it last time. I could write, I guess, it's this. That's the equation for average acceleration. But a big thing that we need to realize now is now we have instantaneous quantities in physics as well. Quantities at points in time and space, or more properly, quantities measurements that apply in the limit as 2 points in time grow infinitely close to each other, right? In the limit as the interval of time approaches zero. So A without a bar above it, or V without a bar above it, means an instantaneous quantity. Instantaneous, and these quantities, these limits, are ultimately defined in terms of calculus language. So the takeaway from last time is that instantaneous acceleration is the derivative of velocity with respect to time. Instantaneous velocity is the derivative of position with respect to time. Therefore, acceleration is the second derivative of position with respect to time. That that's what we're saying. So anything you believe about calculus like starts to apply now and the reverse. Okay. The second equation is what I want to get to, or the second equation is what I want to get to, but I want to get there by continuing to blast through the homework. So we're back at homework 3. I'm going to do a quick screenshot or, screen share. There's I think I have way too many, you don't care, but let me just admit I have way too many windows open or something because there's majorly, hold on, let me just close some things because there's so much latency. Come on. Wow. Maybe that helped a little bit. Um, Okay. Okay. So, okay, just to remind, where we're looking is this sheet, right? We did one and two. Well, we did one. Hmm. I don't want to, okay. Well, I'm going to say quickly for number two, again, you might want to just write this in notes. There's a certain cautionary to question two is actually a little bit tricky, especially if you do the five-step method, which you should, of course. It's very, let me say clearly, it is possible to get the right answer to number two for the wrong reason. And it's sort of important to understand the reason. So I'll somewhat quickly say in number two, it says the car travels at constant velocity for 30 minutes and travels 40 miles. Now, and it asks for instantaneous velocity. Now, at this point, when you got this question, we didn't have an equation for instantaneous velocity or a constant or anything. Or frankly, even if you remembered, and so you weren't assumed, I mean, you were not held responsible for that. Like, right? We're building physics knowledge here, one step at a time. And not so even if you knew from high school or something that instantaneous velocity is a derivative, they still didn't like describe a function or anything here. Like I don't know how you would do slope of the tangent line or something to get instantaneous velocity. So they're asking for instantaneous velocity. It's got to be like figure outable without some elaborate knowledge base. So what do you do? Well, the only thing we know at this point in question two, by the time we've gotten question two, the only thing we know in physics really is that average velocity equals displacement per time. That's what we know. That would be my step three GDP, that average velocity is displacement over time. V bar equals x minus x naught over t, okay? So then I'd plug in, as many of you probably did, I would plug in my displacement, which is, 40 miles, and plug in my time, which is a half of a hour, right? And I would get 80 miles per hour, which I know for many of you got, right? And 80 miles per hour. Okay, so I would get 80 miles per hour, but now I have to say, let's be very clear. That's not the answer. I mean, it is, that's not, I'm not done. Like I can't circle that and say step five, FAC, 80 miles per hour, because just beware and stop me if this is not clear. What I just figured out was the average velocity. That's not what it's asking. It's asking instantaneous velocity. I think what I'm really trying to say to everybody before I move on is do that equation, that definition that we have, displacement over time, that does not tell you velocity at a moment. It tells you velocity on average between two moments. However, the other key piece of information in this problem is that, I mean, it says somewhere um, a car travels at a constant velocity for 30 minutes. Okay. It said, so that's an information piece that I've not used yet. It says the car never sped up nor slowed down nor turned. So if I know the average is 40, 80, then I can say, like, if, I mean, I almost want to write this, I could literally write as part of step four now. The other piece of information that was given to me is that V equals V naught. I almost want to, yeah, like if you write V equals V naught, that is a symbolic notation way of saying the velocity never changes. Whatever it was at the beginning is what it always is at any moment. That's a way of saying velocity is constant, right? And if that's true, if V equals V naught, then V must equal V bar, right? If you know that the velocity is never changing, then you know. So, I mean, it's like, okay, I'm dragging this out, but it's like saying, I know that Lunar's average in this class is a 95. For example, I'm just saying, right? We hope it's 100. I know Lunar's average in this class is 100. And I know that she always got the same score on every single exam in the class. So what did she get on the third exam? Well, like if right, if I tell you those two facts that her average is 100 and she got the same exact thing on every exam, Okay, then I could say what she got on the third exam. But if I just told you her average is 100, well, 100 is kind of a weird number because if I just told you her average was 95 and asked you what she got on the third exam, you don't know, right? So I'm trying to make clear that yes, in the end of the day, because V equals V naught, which must then equal V bar, then what you solve for V bar turns out to be V in this question. The answer is 80. Oh, and there's something in the chat. I'm going to look in a second. But why did I just take you on that big romp and frolic? It's a little bit obnoxious. I'm saying be sure that you know that the answer, that you can't just stop. You can't just divide displacement by time and call that the answer. You have to go a step further. But really what that's all trying to say is, if you think about it, on that one, you didn't need any calculus at all, right? You don't need, what you need to get an instantaneous quantity is a sense of larger context. That problem is trying to show you that if you want to know what's happening in one frame of a movie, as long as you know what happened throughout the whole movie and you know the pattern from frame to frame, then you could figure out any one frame. That's what calculus is in general. When the problems get harder, when the car is like speeding up, it's not going constant velocity. As long as we know the pattern at which it's speeding up or accelerating, as long as we know the function, then we can always zoom in from the larger context of the function. We can zoom in and take a particular point, take the slope of the tangent line at a particular point. That's what calculus is doing for us. It's just saying as long as you know context, you can zoom in to individual event. Okay, so that's why this turns into calculus now. Okay, so that's question two. I overspoken of things in the chat. So hold on. And then I'm going to switch the board, obviously, and start writing things down. Chat, where did chat go? In fact, let me, yeah, all right, that's fair. I was worried about that's totally fair. Hold on, sorry. Okay, very fair. I love this class. So two of you, one person publicly, one person privately, is basically saying, dude, you just said all that. You didn't write it down. Like, I don't know what you. So, all right, fair enough. Hold on, let me stop the share. And write, yeah. And I'll thank you for your honesty. And by the way, those of you who are telling me to write this down, that counts in the portal of please go back. All right, so hold on. So yeah, I should have. Oh, I should have from the start. Hold on. Okay. Okay. Okay, I'm going to turn the page and say, but okay, it's sorry, I did. Okay, so this is the problem, right? Step one, there's my diagram. In fact, pattern. And notice in step one, like we know the thing goes 40 miles. We know it takes a half hour. Um, but the other, what I'm trying to say, this is a big point I'm trying to say. The other key point they told us is that velocity is constant, or maybe they said speed is constant. But so the way to write that symbolically, Like by saying constant, they mean it's not changing, right? And so the way we say that mathematically is we're saying the velocity at any moment, v, is the same as what the velocity was at the first moment, v naught. Like that. And this is one of the big things I'm saying to the whole class. Like whether you heard the whole thing I just said, like in general, that's not a new equation, right? I mean, that's not a memorize, but it is a piece of notation to memorize that if I say v equals v naught, that means velocity is constant. Someone maybe in the chat, maybe one of the two people that asked me to write this down, or maybe someone else, just tell me if that makes sense. Like when I say from now on, bleu equals bleu naught, that means bleu is a constant quantity. Maybe someone should affirm. If you do get that, give me a thumbs up or something. Um, Oh, thank you. Okay. Also, oh my God, I love that. Okay, okay, thank you. Thank you. Okay. So that and that's points, right? So okay, so that's my step one. I'm also trying to say that's real information. Don't think that like they told us 40 miles, they told us a half hour, but they're also telling us the velocity never changed. That is info. So then step two, the question is, okay, at the 18th minute, the 42nd second, what's the velocity? That's like a very obscure sounding question, right? But then step three, I'm saying at this point, all we know for GDP, for a general definition and principle, like when you were assigned this homework, I hadn't said anything about like limits or derivatives or anything. And I'm trying to say, again, this is why I warned you about lab. The good news and the bad news of physics is you get questions, you're supposed to think about things before they're unraveled, before they're explained. That annoys people, especially at the beginning of physics. But let me tell you why. Because that's really what physics is. And that's really what science research or science is. Like the thing of doing science is figuring out things that haven't been figured out before. But the magic, the amazingness of science is that that can be done. Like, no, I don't want to dwell on this too much, but we're not trying to be unfair to you at all. Or disorganized. We're trying to take you on the same path that any physicist that ever invented any of this stuff or discovered any of this stuff did. Like every new equation, like a lot of people will think, well, how am I supposed to do this if I don't have the equations yet? Well, the people that came up with the equations didn't have the equations yet, right? The equations are actual discoveries that make sense as long as you're using everything you have from before. So, saying if you go into this the good news of that is you don't get like if you don't know something going into one of these things, don't assume you missed it. Assume this is somehow figure outable from what you do know already. So what do we do know already? We know this. Right? This is my step three GDP. That's all I know. And notice again, I'm just trying to like now, as long as I'm doing this, let me notice this V has a bar over it. Average velocity is displacement over time, right? That's all I know. Step three. Um, so now step four, I plug in, 40 miles over the 1/2 hour, right? So V bar equals 80 miles per hour. Now, what I was yelling about before, without writing anything down, my big point here is that not the end of the problem. Wait, someone's here. Okay. Like, and this is part of the purpose of the five-step method, where we drag things out even when they seem easy. We're dragging them out because sometimes things seem easy and they aren't necessary. Like, what I'm saying is, when you circle an answer in step five, you're always supposed to like bring that back to whatever the question was in step two, right? Like in step two, the question was at time equals blah, what is V? The question in step two was what is V? Not what is V bar? That's what I'm trying to say. It's asking you for instantaneous velocity. Here, right at this moment, I have average velocity. That's not the same thing. So I'm not done. What I have to say is, but we were told that V equals V naught. We were told that V never changes. Therefore, V bar must equal V or V naught. I'm saying in English, I'm saying if you're told that the velocity never changes, then whatever the velocity is at any given moment, okay, A must be the same as what it was at the beginning, but B, whatever the velocity is at any given moment must be the same as the average velocity. I'm not saying that's always true. That's not a memorizer. That's not a triple equal sign. But I'm saying if the velocity is constant, then the instantaneous, I'm basically saying this. This was the other part I was yelling at that you couldn't follow if I didn't write down. If V equals V naught, then V equals V bar. Like V, here's what I'm trying to say to everybody, and I will move on. This is a where triple equal sign are different from double equal sign. Triple equal sign V does not equal V bar. That's a very important lesson for right now, for this week. Like instantaneous velocity does not mean the same thing as average velocity. And the way of figuring them out is not the same. The equations are not the same. One is a derivative from calculus. One is an average, a simple fraction. They are not meaning the same thing. However, if V is V naught, if average velocity is, if velocity is constant, well, then yes, instantaneous velocity and average velocity will be the same thing. Not triple equal sign. They'll turn out to be the same thing, double equal sign. This was the example of someone in the class taking exams. I'll use a different example. Muhammad, like say Muhammad has a 95 average in the class. And I ask, what did he get on the third exam? You don't know. I don't. I can't just say he has a 95 average. So what did he get on the third exam? No one knows. But if I say he had a 95 average in the class and he always got the same thing on every exam, well, then you know what he got on the third exam. It's the same thing he got on the fifth exam, which must be the 95. Because if that's his average and he never deviated, like he never got anything lower, then you understand, right? So that's what I'm saying. Also, if you're still with me and trying to get your money's worth after if you feel like you've heard the same thing 4 times, when I write IFF, I don't want to squeeze this in. If from now on, piece of notation,
Take my bagel.
I would eat the bagel too. If I write IFF, that means if and only if. I'm going to use it a lot. Okay. So that's, I know so therefore, to finish the problem, thus here, V equals V naught. So at T equals whatever whatever it was, 18. And that is step 5. Okay, so thank you for telling me to write that down. Maybe now I've taken a bit of time on it, but that's what I was trying to say. There's a couple of conceptual takeaways in there I hope you saw. Maybe someone could tell me I would appreciate it if, well, one of the people who asked me to write that down, if they could just tell me in direct chat or something, if that worked or if it's clear now. Um, Thank you. Okay, awesome. Okay. I don't know if that was one of the people that was in the bit. Okay, great, fine. Um, Again, but what's oh, great. Okay, thank you. Okay, awesome. Now, the secret takeaway, why did I spend, I mean, look, that is not the hardest problem. You didn't have to do any calculus to do it, but secretly, that's the message I'm trying to get across, is that calculus also is like anything else in physics. Calculus is something that was discovered and invented by human beings, not by gods I mean, it may originally be, you know what I'm saying. The calculus that we do was developed by human beings who are not perfect and who are not necessarily geniuses in some way that you're not or something. I mean, some of them are, um, but it's not magic. It's a step-by-step reasoning from knowledge that we already have. So this is a way, this problem technically is calculus. It's just very, very straightforward, clear example of calculus. What do I mean by calculus? I mean using a larger context to figure out, to zoom in and figure out what's going on at a point. Using a larger curve to figure out what's going on at a point. Where calculus comes in is, yes, harder and harder examples, but it's always this type of reasoning, just taken one step at a time. So you don't need to have already known calculus to do calculus. You just need to do calculus. All right, you get my point. So the next, I think. So the next question, moving on. All right. So now, oh, and I know it says something about assigned reading, and then it mentions a web. I've since changed the document. Sorry, I should really, in fact, actually, well, it doesn't matter. I've changed it, so don't worry about assigned reading or web page. But in question 3, it now gets into average acceleration. So this is average acceleration, right? And this is the definition, right? And notice it's just like it's not a coincidence that it has the same format. So basically, we're saying average acceleration is slope, whereas instantaneous velocity, sorry, average acceleration is slope, instantaneous acceleration is slope of the tangent line, right? Average velocity is slope, instantaneous velocity is slope of the tangent line. And then you might say, well, wait, didn't you just say the same thing twice? How can they both be slope and both be, because it depends what the graph is. And you may want to write this down. Average velocity is the slope of on a position time graph. Average acceleration is slope on a velocity time graph. Right? Okay. So right now we're talking about averages. Okay, I'm gonna move faster here. So I'm not gonna do the step method now because I want to start making tracks. I'm just gonna sort of say answers or jot down things. So stop me if you need more. But like, so 3A. Okay, we're gonna talk about this for a second. You could write in the steps and the diagram and all that. I'm just saying the answer to A of 3. I know I mentioned this yesterday, but oh, something in the chat. Sorry. Hold on. Oh, great. Okay. So the answer is 30 miles per hour per minute. Now and that's it. You don't have to convert units or anything. It's asking you for what is the answer in miles per hour per minute. So you don't have to convert or anything like that here, unless you want to celebrate a different holiday. You don't have to convert or anything. But notice the answer is miles per hour per minute. I'm going to write this again. I could write it like this. Now, I want to emphasize that for a variety of reasons, that may look like a very awkward answer to you, or it might even to some of you look illegal or scientifically illegal. It's not, it is awkward, but it is not illegal, and it is absolutely meaningful. What we're saying here, so there's two units of time in the denominator. That's right. They're not the same unit of time. That's okay. Maybe they will be in part B. But what this means in English, I mean, notice acceleration has two units of time in the denominator. Not a coincidence, because acceleration is the second derivative of position with respect to time, right? And what we're saying is we're not saying that every minute this car travels 30 miles, nor are we saying that every hour this car travels 30 miles. What we're saying is every minute this car changes its speed by 30 miles per hour. I'll write that down. So that's why time is coming in twice. We're talking about a change in velocity per time. Velocity already makes a reference to time. And then we're talking about how much that's changing in time. The independent variable is time. We're invoking it twice. So it comes into the denominator twice. Do they have to be the same? No. In some way, there's advantages and disadvantages of both. That's why there's a part B for us to answer in a second. But in part B, I mean, in part A, we're saying hours and minutes because for many of us, that is easier to picture. That's more intuitive. Imagine every minute the car speedometer shifts by 30 miles per hour. Like 30, for those of us who can picture speeds in miles per hour, this is something that you can. So in other words, I'm going to say this and move on. What this means is when the whole thing started, maybe it's going not at all. Then in 1 minute, it's going 30 miles per hour. In 2 minutes, it's going 60 miles per hour of speed. In 3 minutes or at 3 minutes, it's going 90 miles per hour of speed. How far it's gotten, I haven't figured out yet. I don't know. But I can tell you this by 3 minutes, if you're following what I'm saying, I'm going to move on. But if you're following what I'm saying, you'll understand that in 3 minutes, this car has not traveled 90 miles. At the end of 3 minutes, it's traveling at a speed of 90 miles per hour, but it hasn't traveled 90 miles. Why am I saying that? Because up until that moment, it's been going slower than 90. It hasn't been going 90 miles. Sorry, let me start that again. At the end of 3 minutes, it has not traveled 90 times 3 miles. It has not traveled, well, it has traveled 90 miles. It also hasn't traveled 270 miles. I'm going to move on in a second, but like, what has it done? Something in between. We'll explain in a minute, but it's speeding up and speeding up and speeding up. Well, for 3 minutes. So it's never going 30 miles an hour until the very last moment. All right, I'm just going to say this and move on. If you don't follow what I'm about to say, don't worry about it just yet. But look, it started at zero. Should I just move on? Okay. I'm just going to say this. I think that the car actually will have traveled 135 miles by the end of those 3 minutes. In 3 minutes, it'll travel 135 miles. Now, I'm not expecting you to be able to do that in your head. You're starting to get it. So should I dwell on this point for a second or should I move on? Wait. I don't know if that means, oh, you are, okay. I'm just going to say this. And I do want, look, the larger point I want to make to everybody is do not take this to mean that in 3 minutes it will have gone 90 miles. Take it to mean that in 3 minutes it will be going a speed of 30 miles per hour. That is two different things. Actually, I'll just leave it at that for the moment. I'll expand this point more in the second part. Um, the second part, now asks us to do a unit conversion. It's going to make it look more scientific, maybe more precise, maybe easier to work with in a calculation, but also less easy to picture. The next part says, okay, now that we've said all that, can you like convert and get it in miles second per second? Like, can you make the units consistent, please? Okay. So a little practice in unit conversion, stoichiometry, whatever. What we have is, yeah, what we have is 30 miles per hour per minute, right? Both the times are in the denominator. We want to convert the hours and minutes to seconds. Little confusing because there's two of them. I mean, there's both of them. And often people that, okay, I'm just going to do this once, unit conversion. This is the way we do it in physics. Usually, because I know you've had a lot of it in chemistry and whatever. What people mostly usually know is that there's 60 seconds in a minute and there's 60 minutes in an hour. That's not that part people know. Where people get confused is, am I supposed to like multiply or divide? I never know. And especially if things are in the denominator, am I supposed to multiply or divide? Here's how I think of it. I always just multiply. I always multiply. I always multiply. I always multiply by one because anything multiplied by one, doesn't change the number. Anything multiplied by one is itself. So I always multiply. I always multiply by one. And then the way I decide which units to put on top or which to put on bottom is I just look at which units have to cancel out. In other words, I'm going to go like this. I'm going to say, to get rid of those minutes and change them to seconds, I'm going to say there's 60 seconds in a minute, right? There's 60 seconds in a minute. So I'm going to multiply by some version of 60 in seconds and minutes. But I need the minutes to cancel out and I want to be left over with seconds, right? So I'm going to put the minutes on top. And I'm going to put the seconds on the bottom where I want them to land and end up. So if I do that, then I know that the 60 must go on the bottom because there's 60 seconds is equal to 1 minute. I've in effect then right? 1 minute over 60 seconds is like X over X. I mean, it's the same number, one. That's what I'm trying to do. In any unit conversion, I'm just trying to always multiply by some version of one that makes the units cancel out. So the minutes will cancel and I'll be left with seconds on the bottom, which is what I want. But now I have to do it again because I also have to get rid of those hours and turn them into seconds. So I'm going to do it again on the next line. Okay, I want the hours to cancel and I want seconds on the bottom. How many seconds are there in an hour? Well, 60 times 60, right? So I don't know if you could do that in your head or not, but I mean, it's like 6 times 6 with two zeros. Sorry. Just making it clear. So 3600 over what, right? You see what I'm doing? So I always multiply and I just arrange the fraction so that things cancel appropriately. And so I'm going to get 30 over 60 times 360 miles over second squared. I'm just going to the next page. Which is really, so I wrote 30 and that means 1 over 7,200. You could leave it that way, but to make it a little bit more clean or yeah, I guess clean. I mean, that's a valid, but I would say. And sorry, this house is. So I think this is the answer. I'm going back to the chat. What time is it? 10. Okay. Oh, this ends at 10:40, right? Okay. So I think that's the answer. Let's now it looks a little bit more precise than now it means the same thing as the other answer, right? It's just another way of saying the same thing as answer A. It's in scientific notation. It's a little bit more scientific looking. The units are in miles per second squared. Of course, a more standard, I mean, that's a little strange that it's in miles. It's not the metric system, it's miles, but that's okay. Just notice that in the end of the day, velocity units are measured in meters per second. Acceleration units are measured in meters per second squared. But that doesn't mean we're turning time into something two-dimensional. It just means we're in time twice. Time is the independent variable twice. And by the way, that's like a hint or a really and that's because acceleration is the second derivative of position with respect to time. And that's why the answer to lab 2, which I think you know at this point, like the pattern of bolts that worked in lab 2, the spacing of the bolts on the string, as I think you know, is ultimately the perfect squares, right? Whatever your first bolt was, whether it was 1 centimeter or say the first bolt was 1 centimeter from the edge of the string. Then the next bolt was at 4 centimeters. Then the next bolt was at 9 centimeters. Then the next was 16, correct? Or if the first one was at 3, then the next one was 3 times 4, 12. Then the next one was 3 times 9, 27, etc., etc. The pattern of the bolts was at the perfect squares because what we're saying here is acceleration makes you move. Acceleration makes displacement be directly proportional to the square of time because it's the rate of change of the rate of change. I guess I'll just leave it at that for the moment, but that's what we're saying here. We've got 16 minutes. I think we have 6 minutes. Um, okay, so acceleration is always measured in those units. Okay. But they didn't have to both be seconds. They could have been hours and minutes as we saw above. Like there's advantages and disadvantages of doing both. Okay, but that you could stop me if there's I'm just looking at the sheet, but stop me if you want to. Okay, wait, we have 16 minutes. I'm going to because I really want to get to number 6. I want to get to the last one. I All right, I'm just going to very quickly, I'm going to write down the answers to number 4. I'm going to try if there's questions, tell me. But if there aren't questions, I'm not going to rabbit hole myself into a discussion. I'm just going to write. So just check your answers. And if you got the same answers, then you're good. And I'm going to go on. We've got 15 minutes. Right. Okay. Okay, let's say east. The stylus is really bad. That's a choice. You don't have to do that, but that's what I'm doing. Okay. Sorry, this stylus is really slowing me down. Hold on. I know someone's in the waiting room. Give me 1 second. That's the answer. See. Okay, very quickly. I think those are the answers. It's 10:28. So again, my goal is to actually discuss question 6 on this sheet, but those are my answers for question 4. So sort of take a moment. If you got the same answers and you're okay, then I'm gonna move on. I'm gonna look in the chat. Hold on. Okay, if there's nothing in the chat, like sort of going once, going twice, I will say the point of that problem, what it's asking in English in question D, it's really just trying to emphasize from here on in, if you understand that acceleration is change in velocity per time, and if you understand that velocity includes direction, velocity or quantity, it includes direction as well as magnitude, right? So it takes into account negative signs. Same thing with acceleration, then. We're taking into account direction. Therefore, positive acceleration from here on in does not necessarily have to mean gain of speed. Positive acceleration could mean moving faster in the positive direction, or just as easily could mean moving slower in the negative direction, right? That's the takeaway here. And same thing with negative acceleration could mean that you're moving forward while losing speed. You're moving north while losing speed, or could mean you're moving south while gaining speed, right? It takes into account direction. All right, so that's the takeaway. Please feel free to ask a question, but if you're not, if there's nothing in chat, then I'm moving on. I'm going to skip. Honestly, the answer to number 5 is the same issue. It's this there. If you get 4, 5 is asking the same thing. Like just take into account direction when you think about acceleration. Now, question 6. Let me take a breath for a second. Well, okay, I will cut to in number 6. Well, I'll write the answers. The averages are as follows. And hold on. Oh, I always, all right. 5, 14, 30, 55, 81, 130. I believe. Sorry. You can correct me if I'm doing this one sort of in my head. You can correct me on the last one if you don't agree. And please do correct me if you don't agree with the last one. But here, do you agree on the last one? Can anybody give me a confirmation or a denial on the very
I
last?
got 20.
You got 20, you said. Okay, wait.
Yeah. I
Okay.
probably did something wrong though.
No, wait. Okay, that's an important one to you may be right. Hold on. 5, 14, 30, 55, 91. Oh, sorry, my bad. 140 divided. Oh, no, you're absolutely right. You're absolutely right. Oh, that's really good. And you should submit many points for that. You're absolutely, was that Gabriella? Sorry.
Yes.
Yes. Okay. So remember, submit for respectfully corrected that portal, but also for voice and because you just used your voice and like other things. That's awesome. Yes, 20. Sorry. Okay. Thank you. So we have 7 minutes. Here's the deal with this. I'm sure many of you realize, but this is like super important. I'm sure many of you realize that for any of these, you could add up all the numbers and divide by the number of numbers to get the average, as you always do in a math class or whatever. But as I'm sure many of you realize, presumably Gabriella realized, you had to do that for the very last one. You had to add up all the numbers and divide by 7, which I did in my head and I did it wrong. You had to do that for the last one, but for all of the other ones, the reason I could do them quickly, the reason you can do them quickly, is for all the other ones, you didn't have to add up and divide by 7. You could, but or you could just sort of stare at the middle number, and somehow that was the answer, right? Like in the top one, the average was the middle 4, and in the same thing with the second one and the third one, and the fourth one, and then even the fifth one. Even though there was no middle number, there was like 6, items. The what would be right in the middle between the two middle numbers, 11, was the answer. So you could just somehow get the middle for all of them, except not the last one. Now, one might say, well, because all the ones had patterns except for the last one. But the last one definitely is a pattern. In fact, it's the pattern that is the answer to lab 2, right? And a quick thing about lab, okay, no, or I'll keep going. So they're all patterns, but but the very last one is a different kind of pattern. What we see is as long as values change by a constant amount, a constant interval, right? Which is true of 1 through 5, but not true of 6. Like 1 through 5, right? Like, the numbers are increasing by 1, or they're increasing by 2, or they're increasing by 5, or they're decreasing. And even number 5, by the way, where you had to sort of switch around the numbers and put them in order yourself, still, once you did that, you see that the numbers are increasing by 2 always. So as long as the numbers are always increasing or decreasing by a constant amount, then it turned out that as long as, like if or and only if the numbers were increasing or decreasing by a constant amount, then the mean value was the median value, right? The arithmetic average was the middle number. And specifically, and specifically, notice this. When I say the average was the middle for any of these constant change lists, starting to sound a little bit like lab 2 maybe, then really, in order to get that middle number, all you had to do was average out the first and the last. Like look at the first list. The average is 4, right? Why? 1 plus 7 is 8 divided by 2 is 4. Or the third list, 3 plus 15 is 18 divided by 2 is 9. You instead of averaging them all, you could, no matter how long the list is, you could average the first with the lowest with the highest and skip all the stuff in the middle because all the stuff in the middle is changing by the same amount. Everything, right? So, what does this have to do with physics? So, I'm saying, as long as change is by a constant amount, then the average is the middle, and the middle could be gotten by just averaging the endpoints. Think now, we have 2 minutes. Imagine that each one of these numbers is a velocity. If each of these numbers are velocity, then what we're talking about is what you're really discovering in lab 2. We're talking about an acceleration that is a constant. We're talking about velocities changing but by an unchanging amount. That's what you're discovering in lab 2. The string that works because evidently when things fall, they do speed up, but they speed up by the same amount all the time. In other words, we're looking here at the condition known as constant acceleration. Remember, and we have 1 minute. Remember, I said at the beginning of class, if you write like v equals v naught, that means constant velocity. If you write a equals a naught, that means constant acceleration. It means there is a change in velocity, but there's no change in the change. And when that is true, if and only if that is true, then the average velocity will be the average of the first and last velocity. This is our first equation. This is the end of class, but this is a real big equation. It's a double equal sign, not a triple. It's our first one because it's conditional. It's saying the average velocity is the average of velocities if and only if acceleration is a constant. When acceleration is a constant, position is a quadratic function of time. That's why your string that has the perfect squares, the fact that your string that has the perfect squares works means that when things fall, they must be falling at a constant acceleration. When acceleration is constant, the average velocity is the average of the velocities only when acceleration is constant. Okay, that's class. You've been very, very attentive and very helpful. I think there's things in the chat. Oh, so, okay. Hang on, you can go, but I'm not going anywhere. If you had a question and you want to stay for a second, please, I will answer any questions or tell me your text. But sorry. So, 20. Oh, it's
Thank
20.
you.
20. Okay. All of you that corrected the 20, you can get points. Just on there. Okay. Have a good day. Have a good day. Yes. Okay. Have a good day. And I'm turning off the recording, or am I? Yes, I am. Have a good day.